This is Chapter 12, Part 1. Writing an equation of the inverse relation of the following. To do that, all you need to do is switch x and y. Number 1, x equals 4y minus 5. Number 2, x equals 3y squared plus 2. Number 3, y squared minus 3x squared equals 3. And number 4, x equals the square root of y minus 5. You'll notice in the case when y equals 1 in number 7, yx equals 1 when you switch the x and y. They're exactly the same. So the inverse is itself. And you'll notice that it is symmetrical. The graph that is shown in green is symmetrical with respect to the line y equals x. So if the inverse relation is the same as the relation, it will be symmetric with respect to y equals x. So if we wanted to test for symmetry with respect to the line y equals x, find the inverse. The inverse in number 8 is 3y plus 2x equals 4. You notice these two equations are not equivalent. So it would not have symmetry with respect to y equals x. In number 9, yx equals 10. They are equivalent. So we would have symmetry with respect to y equals x. In number 13, x equals the absolute value of 2y. They are not equivalent. So they are not symmetrical with respect to y equals x. Number 14 says find equations for f inverse of x for the following. Remember, this is not an exponent. Negative 1 is not an exponent there. It means f inverse of x. To find f inverse of x in number 15, remember f of x is the same as y. So find the inverse. X equals 2y plus 5. But solve for y now. And you would have x minus 5 equals 2y. And so y would equal x minus 5 all over 2. F inverse then, replace the y with f inverse, is x minus 5 all over 2. Number 16. Switch the x and the y. Remember, this is y. X equals 3y minus 1. Solve for y. X plus 1 equals 3y. So y equals x plus 1 all over 3. Replace the y with our new symbol, f inverse of x. And you have f inverse of x equals x plus 1 all over 3. Number 18. X equals the square root of y plus 5. Square both sides. X squared equals y plus 5. So y then is x squared minus 5. F inverse of x then is x squared minus 5. Go to 12.3. We'll go back to 12.2 later. Number 1, we want to convert this to log equations. 3 equals log to the base 10 of 1,000. Remember, logs are exponents. 3 is an exponent. And the log equals 3, the exponent. So logs are exponents. 1/5 in number 3 equals log to the base 32 of 2. Number 5 minus 3 equals log to the base 4 of 1/64. 7c equals log to the base 7 of 2. Now go backwards. Remember, logs are exponents, and the base is below the g. So in number 9, 4 is the base, t is the exponent, and 7 is the outcome. So that is the exponential form. In number 10, 7 is the base, h is the exponent, 11 is the outcome. Number 13, 10 to the minus 3 equals 0.001. Now let's solve equations. Usually when you have a log equation, you put an exponential form and go from there. In number 17, 4 to the x equals, to the 2 equals x. 4 squared is x. So x is 16. Number 20, x cubed equals 8. So x is 2. Number 21, 3 to the negative 1 equals x. And negative exponents mean drive it down to the bottom. So 1 over 3 to the 1, or 1/3. Number 23, 27 to the 1/3 equals x. The 1/3 exponent means cube root. The cube root of 27 is 3. Number 24, 16 to the 1/4 equals x. Then the 4th root of 16 is 2. 25 star, 4 to the x equals 1/8. Well, 4 is 2 squared. 1/8 is 2 to the minus 3. So 2 to the 2x equals 2 to the minus 3. Therefore, 2x equals minus 3, so x is minus 3/2. Number 26, we want to do the rest of the problems. They're worth it. Remember, logs are exponents. 26 is really asking 2 to what exponent is 8? And that would be 3. So here's your check. 2 cubed is 8. Do not use a variable here. There's no variable. It would be a mistake, for example, in number 27, if someone did this, 4 to the x equals 16, and then said x equals 2. Well, that still doesn't answer my question. What is log to the base 4 of 16? It is 2. So if you're going to do this stuff, do it right. Number 28. 10 what exponent is 10 cubed? It's 3. 29. 5 to what exponent is 5 squared? 2. 30. 10 to what exponent is 0.01? That'd be negative 2. Here's your check. 10 to the negative 2 is 1 over 100, or 1 over 10 squared, which is 0.01. 31. 10 to what exponent is 1,000? That's 3. 32. 5 to what exponent is 1? 0. 33. 5 to what exponent is 5? 1. And here's some more. Number 34. 1/2 to what exponent is 8? Well, 1/2 quantity cubed is 1/8. So 1/2 to the negative 3 is 8. 35. 35 could be rewritten log to the base 2 of 2 to the third, because 2 to the third is the cube root of 2. So 2 to what exponent is 2 to the third? 1/3. 36. 4 to what exponent is 256? That would be 4. Number 37. 2 to what exponent is 64? That would be 6. 38. 1/7 to what exponent is 49? Well, 1/7 quantity squared is 1/49. So this must be minus 2, because you have to flip it over for your notes. So the exponent has to be negative to flip it over. 39. 6 to what exponent is 1 over 216? Well, you know that 6 cubed is 216, so this must be minus 3. 40. 8 to what exponent is 4? Well, we know that 8 to the 1/3 is 2, so it must be 2/3, because I have to square 2 to get 4. 41. 9 to what exponent is 243? Well, I know that 9 to the half is 3. Then I would have to raise that to the fifth power to get 243. 3 to the 5th is 243. So this has to be 5 halves. 9 to the 5 halves is 243. I believe that's the end of the line there. Okay, so let's now go back to 12:4. In this section we have 3 log laws. The first one, log to the base b of AC is log to the base b of A plus log to the base b of C. So at number 1, that would be log to the base 2 of 16 plus log to the base 2 of 8. Now log to the base 2 of 16 is 4, and log to the base 2 of 8 is 3, so the ultimate answer is 7. Number 6. This would be log to the base r of v plus log to the base r of k. Number 7 is log to the base a of 7 times 10, which is log to the base a of 70. And number 9 would be log to the base c of 9, or is that g? That's g. GW, like George Washington. Okay, law 2. Log to the base b of a to the c is c times log to the base b of a. Number 10 is 5 times log to the base a of x. Number 12 then would be 9 times log to the base c of y. Our third log law. Log to the base b of a over c is log to the base b of a minus log to the base b of c. So 13 would be log to the base a of 17 minus log to the base a of 5. And 14 would be log to the base t of u minus log to the base t of m. Now remember, we have three log laws. You remember what they are? I think it'd be a good idea to review them right here. Law 1, log to the base b of ac is log to the base b of a plus log to the base b of c. Law 2, log to the base b of a over c is log to the base b of a minus log to the base b of c. Try to write your base under the g. Law 3, log to the base b of a to the c is c times log to the base b of a. We want to use those laws now to help us do the following problems, like number 16. This would be log to the base a of x cubed plus log to the base a of y to the fourth plus log to the base a of z, which would be 3 times log to the base a of x plus 4 times log to the base a of y plus log to the base a of z. Number 18 would be log to the base b of xy cubed minus log to the base b of z to the fourth, which would be log to the base b of x plus log to the base b of y cubed minus log to the base b of z to the fourth. So this would be log to the base b of x plus 3 times log to the base b of y minus 4 times log to the base b of z. 18. This would be log to the base b of x minus log to the base b of y cubed z to the fourth, would be log to the base b of x minus, well, let's think of this separately. That would be log to the base b of x cubed plus log to the base b of z to the fourth, which would be log to the base b of x. And let's go ahead and put this 3 here and this 4 there, and then distribute the negatives. So minus 3 log to the base b of x minus 4 times log to the base b of z. Okay, number 20. Now we go backwards. This would be log base a of x cubed plus log base a of y to the fifth minus log base a of z to the half, which would equal log base a, let's see if you can see this, x cubed y to the fifth over the square root of z. I skipped a step. Is that okay? Okay, money problems. This formula you need to have committed to memory, even though we're not playing with the calculator. How much money will you have if $340 is invested at 8% compounded annually for 25 years. Well, A would equal 340 times 1.08 to the 25th dollars. That's the best you can say without a calculator. Number 24. Here, we know that A is 8,543, and the principal is 6,000. And it'd be times 1.07 to the unknown number of years. Well, we need to solve this. So divide both sides by 6,000. Now we have it in exponential form. X then would equal log to the base 1.07 of 8,543 over 6,000, and that would be years. Without a calculator, that is the best you can do. Number 25, same kind of situation. We want $295. We're starting with a principal of 4,000. The interest rate is 0.09. We don't know the number of years. The first thing is to divide by 4,000. Now it's in exponential form. Put it in log form. X equals log to the base 1.09 of 9295 over 4,000 years. And that ends that.